The first one is iodide, so it's iodide to iodate. So I minus 2, I is going to combine with other. Then thiosulfide is oxidized almost quantitatively to sulfate. It means to say your sulfate, thiosulfide is converted to sulfate. So here you can see S2O3 will convert to SO4. So this is thiosulfide to sulfate. So this is the reaction. So you can make like that also. So how we are made in yesterday's class, like all 3 steps, you can make like that also. So you are, don't worry, like ma'am, yesterday we read like that. Now we are showing this one sentence reactivity. So you can do both the things, no problem. Then with manganese to oxidize manganese, MnO2, so that is zinc sulfate, or you can use zinc oxide. So it means to say almost manganese, zinc, copper, this and all comes under one category. So it will have the same properties of one kind of thing. So that's why they were just giving the example of salt, manganese salt. So if you want to take that as an iodide form, as an iodide formally ತಗೋಬೇಕು ಅಂತ ಹೇಳಿದ್ರೆ, voice audible ilva? Am I not audible? Only a little bit of things in F block elements. So why we are call it as inner transition, and we have 2 types, that is lanthanide and actinide. What are the function of it? So idishtu odidre saku ansutte. So first of all, we need to know that where that exactly F block element is located. So F block element is located just below your entire periodic set of S, P and D block. So S, P, D block ಏನು ಸೆಟ್ ಇದೆ ಅದರ ಕೆಳಗಡೆ ಇರುವಂತಹ 2 line structure is called as S block elements. So it is not separated from your periodic table. It is just a picken part of your D block element. ಅಂದ್ರೆ ನಿಮ್ಮ D block element ಇಂದ ಪಿಕ್ ಮಾಡಿರುವಂತಹ ಒಂದು part of F block element. So if you see the periodic table, ನೀವು periodic table ನೋಡೋದಾದ್ರೆ it is a continuous part of your screen display ಆಗ್ತಾ ಇಲ್ಲ ಅಲ್ವಾ? ಒಂದು ನಿಮಿಷ. ಪಾಸ್ ಆಗಿದೆ, just a second, I'll open it. I can show you. So see here, yes, this one is the manganese to S. Note it down. Note kodi. So F block element delta ಇದೆ ಅಲ್ವಾ? So it's just a taken part from your D block element. So if you finish this, I can show you the periodic table. See. Yes. I'll show back to you. ನಾನು ವಾಪಸ್ ಆ ಸ್ಕ್ರೀನ್ ತೋರಿಸ್ತೀನಿ, don't worry. Okay, Kavi, no problem. I'll show it again, no problem. But look at this. So this is your periodic table. So you can see here, it's a continuity part. Like here, the star represent the unpaired, or it's unpaired. It's a first group element. This single star represents, it's a picken part. So from that, something is going to be started. And from this 2 star, again, one more set of group is going to be started. So now, let us see that. Okay. Here, so from this, we are going to derive this component. And from this, we are going to start up this. So where actually F block elements is initiated means it's just start from beryllium. It's just a in between of beryllium and hafnium. So it's in between beryllium and hafnium. So you can see 15 elements in both of the groups. So 56 ವರ್ಗೂ ನಿಮ್ಮ D block ಅಲ್ಲಿ ಇರುತ್ತೆ. After 56, from 57 till 71, you can see those elements will comes under the category of F block element. This is the first group or first series of your F block. And second series will start from radium to Rutherford. So between these two, your second set of F block elements is going to be started. So that is starts from 89 to 103. So we can say that this F block element is not separated from the periodic table. It is just taken pick part of your D block element. So then we given the name for those two series as an lanthanide and actinide. Why we are giving the name? Because the initiate element, the first element of those series are called it as lanthanum and actinum. So only because of that we are saying this? No. This category will replica from 57 to 71. This kind of elements or group of elements will showing the physical or same property has repulsion, or you can compare it's a reflection of your lanthanum. ಅಂದ್ರೆ ಈ ಒಂದು ಲ್ಯಾಂಥನೈಡ್ ಸೀರೀಸ್ ಅಲ್ಲಿ ಇರುವಂತಹ ಎಲಿಮೆಂಟ್ ಗಳ ಪ್ರಾಪರ್ಟಿನ ನೀವು ನೋಡಿದಾಗ ಅದು ಲ್ಯಾಂಥನಮ್ ಅಂದ್ರೆ 57 LA ಈ ಒಂದು ಎಲಿಮೆಂಟ್ ನ ರೆಪ್ಲಿಕಾಗಳಾಗ್ತಾ ಹೋಗುತ್ತೆ. So it almost show the similar properties of your lanthanum. So that's why this all series will call it as lanthanide. That's the first reason. And we have one more kind of reason also. So ಇವೆರಡು ಒಂದೇ ತರ. So ಅದೇ ತರ actinum replica ಆಗಿರೋದ್ರಿಂದ we used to call it as actinide. So then second reason we have that means this all elements present in your F1 series. So F1 series ಅಂತಂದ್ರೆ lanthanide, F2 series ಅಂದ್ರೆ actinide. That F1 series having 4f valence orbital. So usually we know that F block elements ಅಂತ ಹೇಳಿದ್ರೆ there we can say that the outermost electronic configuration should end with their respective orbital. ಅದರ respective orbital ಗಳಿಂದ end ಆಗಬೇಕು. This is our theme. Now what we need to do, if those can be end with any other F series, ಬೇರೆ ಯಾವುದೇ F shells ಗಳ ಮಧ್ಯೆ ಅದು end ಆಗಬಹುದಾಗಿತ್ತು, but all your lanthanoids will end by 4f series. ಎಲ್ಲವೂ ಕೂಡ 4f series ಅಲ್ಲಿ end ಆಗುತ್ತೆ. So that's why it's a second reason we used to call it as all the elements from 57 to 71 is a replica of your lanthanum. That's why it's called as lanthanide series. It's the same for your actinide series also. It is end with 5f. So you should remember this. Lanthanide is end with 4f and actinide is end with 5f series. Okay. So this is regarding your F block element. So what is the position of your F block? Why we are saying F block is an lanthanide and actinide contraction? And what makes you to get down? ಯಾಕೆ ಅದು ಕೆಳಗಡೆ ಕೂತಿದೆ? Because it doesn't involve in the continuity formation of your D block. D block ಅಲ್ಲಿ DD excitation ಆಗಬೇಕು, ಕಲರ್ ಕೊಡಬೇಕು. ಸೊ ಈ ಯಾವುದೇ ಪ್ರಾಪರ್ಟಿಗಳು ಈ D series F series ಅಲ್ಲಿ ಇಲ್ಲ. So that's why we need to keep it down, but has shown to the according to the atomic number it's continuously, so we can't make a mismatch kind of thing. So that's why it's just put it down by representing in dot structure. Okay, artha aitappa? Can you able to get the point? So now we have some properties ನೋಡೋಣ. So lanthanides are representing in terms of Ln. Ln in the represent ಮಾಡ್ತೀವಿ, use ಮಾಡ್ತೀವಿ. So the electronic configuration, if you see, has I informed you, it's a 4f level. So 4f series ಅಲ್ಲಿ ಇರುತ್ತೆ. The atomic size is not increasing because of the contraction. We used to call it as lanthanide contraction. Lanthanide contraction ಅಂದ್ರೆ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ, you can see if the atomic number are going to be increased, then because of the steric hindrance and because of the shielding effect, atom used to pull the electron towards itself. So that's why atomic size become reduced. Because of that, ionic radius also be reduced. So atomic size will keep on decreasing if you're moving down to the series. So oxidation state. The maximizing oxidation state is +2 to +4 oxidation state because of the more shielding effect. Shielding effect ತುಂಬಾ ಜಾಸ್ತಿ ಇರೋದ್ರಿಂದ outermost electron ನೀವು ಟಚ್ ಮಾಡಕ್ ತುಂಬಾ ಕಷ್ಟ. You can't remove the outermost electron easily. That's why the maximum attaining of your electronic configuration is +4. So this is your periodic table electronic configuration. Electronic configuration ನೋಡಿದ್ರೆ ನಿಮಗೆ ಗೊತ್ತಾಗುತ್ತೆ. So no need to worry about this. Electronic configuration ಬರೀರಿ ಅಂತ ಏನು ಕೇಳಲ್ಲ. So general characteristics ಏನಂತ ಹೇಳಿದ್ರೆ, you can see the melting point range. So melting point range is from 1000 to 2000 and it's a good conductor of heat and electricity. So some properties ಇದೆ, but ಇದು ಸ್ಪೆಸಿಫಿಕ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ ಕೆಲವೊಂದು ಎಲಿಮೆಂಟ್ ಗಳಿಗೆ. It's going to be specific. Yes. Yes, chemical reaction. How this lanthanide will going to be react with the other atom. ಬೇರೆ ಆಟಮ್ಗಳ ಜೊತೆ ಹೇಗೆ ರಿಯಾಕ್ಟ್ ಆಗುತ್ತೆ. So ನಿಮ್ಗೆ ಅನಿಸ್ತಾ ಇದೆ ಅಲ್ವಾ, you can see that there may be some pictorial representation says that somewhat logical answer. No, nothing. So they were giving in what all the ways does lanthanide can be exist in other format. Lanthanide ಯಾವ ಯಾವ ಫಾರ್ಮೆಟ್ ಗಳಲ್ಲಿ ಇರಬಹುದು ಅನ್ನೋದನ್ನ ಕೊಟ್ಟಿದ್ದಾರೆ ಅಷ್ಟೇ. So you can see that lanthanum. So middle what they were showing, it's an lanthanide. So the lanthanide, whatever you are seeing, is here. So the lanthanide can be exist in the form of lanthanide oxide in the presence of oxygen. So if you burn the lanthanide na burn ಮಾಡಿದಾಗ it's combined with oxygen, so it can form a lanthanide oxide. So oxide format ಅಲ್ಲಿ ಸಿಗುತ್ತೆ. So whenever this lanthanide react with acid ಜೊತೆ react ಆಗ it can form the hydrides. Then if you are react with halogen, it can form halides. Then if you are reacting with water, it can give hydrides. Then if you are reacting with carbon at 2773 Kelvin, so it can convert into lanthanocarbide. So then lanthanide nitrogen jothe combine adre it's a nitrate. Then sulfate jothe combine adre it will give sulfates of lanthanide. So what this all pictorial representation says that it can combine with sulfur, it can combine with nitrogen, it can combine with carbon or water, halogen, acid or oxygen, whatever it can be. It can easily, readily react with these components to give a product yield. So ನಮ್ಗೆ ಏನ್ ಪ್ರಾಡಕ್ಟ್ ಬೇಕು ಆ ಪ್ರಾಡಕ್ಟ್ ನ ಈಸಿಯಾಗಿ ಕೊಡುತ್ತೆ. So this is the kind of thing. You can ask me, ma'am, except this, does it able to react with any other, with any some conditions? Yes, if of course it can be, but we need to maintain some what to say conditions. So for example, temperature ಇಷ್ಟರಲ್ಲಿ ಇರಬೇಕು. If you leave that temperature, or if you are crossing from that zone, so it may have the chance of losing the property. So ಅಂದ್ರೆ ಈಗ lanthanide ಆಕ್ಸಿಜನ್ ಜೊತೆ ಮಾತ್ರ ಕಂಬೈನ್ ಆಗುತ್ತೆ, ಸಲ್ಫರ್ ಜೊತೆ ಮಾತ್ರ ಕಂಬೈನ್ ಆಗುತ್ತೆ, ಅಥವಾ ನಿಮ್ದು ಯಾವ್ದೋ ಇನ್ನೊಂದು ಕಾಂಪೊನೆಂಟ್ ಇರುತ್ತೆ, ವಾಟ್ ಸೇ ಹೀಲಿಯಂ ಜೊತೆ ಕಂಬೈನ್ ಆಗಲ್ವಾ, ಅಥವಾ ಆಕ್ಸಿಜನ್ ಜೊತೆ ಕಂಬೈನ್ ಆಗಲ್ವಾ, ಆತರ ಇದ್ರೆ ಇಟ್ ಕ್ಯಾನ್ ಬಿ. ಸೊ ಯಾವ್ದ್ರ ಜೊತೆ ಕಂಬೈನ್ ಆಗಲ್ಲ ಅಂತ ಅಲ್ಲ, ಇಟ್ ಕ್ಯಾನ್ ಬಿ ಫಾರ್ಮ್. ಬಟ್ ಈ 6 ಅಥವಾ 7, ಆಲ್ ದಿಸ್ 7 is readily active with lanthanide. So So without any sources, without any maintaining of the condition, it can be easily convertible. So that is called lanthanide activity. Okay, so ಇದನ್ನ ಈ ಪಿಕ್ಚರ್ ಅದನ್ನ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡ್ತಾ ಇದೆ ಅಷ್ಟೇ. So then actinide electronic configuration. So it's end up with 5. So you can see 5F is the outermost valence electron. So yes, of course, electronic configuration. Ionization size. So ಏನಾಗುತ್ತೆ ಅಂತ ಹೇಳಿದ್ರೆ the size, if the atomic size is going to be decreased, then it should be ionic size also decrease. Ionic size ಕೂಡ decrease ಆಗಬೇಕು. And in 5F series ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ we have less shielding effect. So that's because of the ionic size. So ion already loss ಆಗಿರೋದ್ರಿಂದ it doesn't having much more force to pull it. So in F series, so it means to say in actinide contraction, you can see the shielding effect is poor. So the oxidation state can be exist till +7. So now actinide ಅಲ್ಲಿ ನೋಡಿದಾಗ +4 ವರೆಗಿತ್ತು. So in lanthanide, sorry, now lanthanide ಅಲ್ಲಿ +4 ಇತ್ತು. In actinide, if you are seeing, we can exist till +7. So +7 ವರೆಗೂ you can exhibit the oxidation state. Then general properties or characters. Yes, let us see the application. So what are the major sources and uses of your lanthanide ಮತ್ತು actinide contraction ಅಂದ್ರೆ we used to combine with copper. So copper ಜೊತೆ combine ಮಾಡಿದಾಗ it will give you an alloy. That alloy is more stable than any other metals. That is the first thing. And second thing, V2O5 vanadium pentoxide is used as an oxidizing agent. Vanadium pentoxide na ನಾವು oxidizing agent ಆಗಿ ಯೂಸ್ ಮಾಡ್ತೀವಿ. Then we are using it as an catalyst also. Catalyst ಆಗಿ ಕೂಡ ಯೂಸ್ ಮಾಡ್ತೀವಿ. And your some of the S block elements are used as an used in the manufacturing of polyethylene. Polyethylene na use ಮಾಡಕ್ಕೆ ಅಂದ್ರೆ polythene like your plastics covers. So ಅದರ preparations ಗೆ we are using S block series. Okay, then ಅಷ್ಟೇನಾ? Does we are end up with this? ಮುಗಿತ ಲೆಸನ್. ಸೊ ಇದರಲ್ಲಿ ನಿಮಗೆ ಡಿ ಬ್ಲಾಕ್, ಎಸ್ ಐ ಥಿಂಕ್ ಸೊ ಇಟ್ಸ್ ಎಂಡ್ ಅಪ್. ಡಿ ಬ್ಲಾಕ್ ಎಲಿಮೆಂಟ್ಸ್ ಗಿಂತ ಯು ನೀಡ್ ಟು ಮೋರ್ ಕಾನ್ಸಂಟ್ರೇಟ್, ಸಾರಿ ಎಫ್ ಬ್ಲಾಕ್ ಇಂದ ಯು ನೀಡ್ ಟು ಮೋರ್ ಕಾನ್ಸಂಟ್ರೇಟ್ ಆನ್ ಡಿ ಬ್ಲಾಕ್. ಏನಾದ್ರು ಡೌಟ್ ಇದ್ರೆ ಯು ಕ್ಯಾನ್ ಸಿ ಇಟ್ ಅಂಡ್ ಯು ಕ್ಯಾನ್ ಟೆಲ್ ಮಿ. So any doubts in D and F block elements? I think we are finished with D block. ಮುಗಿಸಿದ್ವಿ ಅನ್ಸುತ್ತೆ. ಒಂದ್ಸಲ ಚೆಕ್ ಮಾಡ್ಬಿಡ್ತೀನಿ. Then you have the coordination compounds.